Hello friends, here in this video we will see a problem based on diesel cycle. Here is the question. Now it is given that the stroke and cylinder diameter of a compression ignition engine that is CI engine is the other name for diesel engine. I'll write it down in the data. Now the type of engine which is given here, it is compression ignition, that is CI engine, and CI engine is the other name for diesel engine, and this diesel engine will always work on diesel cycle. So here the type of cycle is diesel cycle. Next, the stroke and cylinder diameter of a compression ignition engine are 250 mm and 150 mm respectively. Stroke means the stroke length, which is 250 mm, that is 0.25 meter. Next, the cylinder diameter is 150 mm, so capital D is 150 mm. Dividing this by 1000 to convert it into meter, so it becomes 0.15 meter. Next, if the clearance volume is 0.0004 meter cube, so clearance volume is V suffix C, 0.0004 meter cube, and fuel injection takes place at constant pressure for 5% of stroke. So fuel injection is at 5% of stroke. And now from this statement also we can understand that it is working on diesel cycle, that the fuel injection, it takes place at constant pressure. Whenever the fuel injection is taking place only at constant pressure, that kind of cycle would be called as the diesel cycle. So this is another way of identifying the problem. Next, determine the efficiency of the engine. Since we have understood that it is a diesel engine, so its efficiency would be efficiency of diesel cycle. This is the unknown value which we have to calculate. Now this is the data which we have. With the data available to us, we can start with the solution to this problem. And in the solution, the first thing would be, since diameter and length are given, I will calculate the stroke volume. Solution. Since the stroke volume is given by V suffix S is equal to area of the cylinder pi by 4 into d square multiplied by the stroke length L. Now this can be explained by drawing a diagram. Now this is a cylinder which has its top dead center and bottom dead center, that is TDC and BDC respectively. Now this cylinder it will have a piston inside it. So here I am drawing the line diagram of the piston. Now the distance moved by the piston between TDC to BDC, that distance is called as stroke, and it is also called as stroke or stroke length, denoted by L. Next, if I assume that here the diameter of the cylinder is denoted by capital D. This is the diameter. So stroke volume would be from the diameter we are going to get the area, that is pi by 4 into d square, into length, that is area into stroke length, will give us the stroke volume. So this stroke length, it also indicates that the volume here would be stroke volume, and whatever remains, that is above TDC, that volume, this much portion, it would be called as the clearance volume. So this clearance volume is V suffix C, and below that, that is from TDC to BDC, the volume which we are going to get, that would be called as stroke volume, denoted by V suffix S. So now I am going to calculate this stroke volume. Therefore stroke volume will be pi by 4 into, now diameter, it is 0.15 meter, so 0.15 square into length, that is the stroke length, is 0.25 meter. So from this I'll get the value of stroke volume, and it comes out to be 0.004418 meter cube. This is the stroke volume which we are getting. Next, here even the clearance volume is given, so if we add clearance volume and stroke volume, that will give us the cylinder volume. So therefore cylinder volume V suffix CYL, that will be equal to stroke volume plus clearance volume. Stroke volume is 0.004418 plus clearance volume is given in the problem, that is 0.0004. If I add up the values, I am going to get the cylinder volume, and my answer is 0.004818 meter cube. So here I have calculated the cylinder volume. Next, after this, I'll calculate the compression ratio because it would be required in the problem further. So therefore compression ratio, which is denoted as R suffix C, that will be equal to cylinder volume upon clearance volume. Cylinder volume is V suffix CYL, clearance volume is V suffix C. So therefore R suffix C is equal to, the cylinder volume is, as I have found out, 0.004818, clearance volume given in the problem 0.0004. So on calculating this, I'll get the compression ratio, and my answer is RC, R suffix C, is equal to 12.04. This is the value of compression ratio which we are getting. Next, after getting the compression ratio, we should draw the PV and TS diagram for diesel cycle, because without drawing the PV and TS diagram we cannot understand this problem. So the next step is
PV
and TS diagram for diesel cycle. So next, here I am drawing the PV and TS diagram of diesel cycle. PV is pressure volume. TS is temperature entropy diagram. Now for diesel cycle, I'll write down the processes. The processes that take place in diesel cycle are: first process is process 1 to 2. It is reversible isentropic compression. Second process 2 to 3 is constant pressure heat addition. Next process 3 to 4 is reversible isentropic expansion, and then process 4 to 1, that is constant volume heat rejection. So these four are the processes which are there in case of diesel cycle. I'll draw it one by one, first on the PV diagram, next on TS diagram. Process 1 to 2 is reversible isentropic compression. So on PV diagram, it will be shown with the help of a curve. 1 to 2 is reversible isentropic compression, wherein now we can see that the volume at point number 1 is V1, volume at point 2 is V2, so there is decrease in volume, but there is an increase in pressure from P1 to P2. After that, there is constant pressure heat addition. So heat will be added from 2 to 3, keeping the pressure constant. So pressure at point 2 is equal to pressure at point 3. Next, 3 to 4 is reversible isentropic expansion. This will again follow a curve. So it is reversible isentropic expansion, wherein as we see, the volume is V3 at the start of expansion. When the expansion gets completed, it is V4. So this is the expansion process, wherein there is increase in volume, decrease in pressure. Next, process 4 to 1 is constant volume heat rejection. So heat gets rejected, keeping the volume constant. V1 is equal to V4. Next, as there is isentropic compression, isentropic expansion, this curve, it follows the law PV raised to gamma is equal to constant. Next, I'll show the same P processes on TS diagram. First is reversible isentropic compression. It will be shown with the help of a vertical line. So this vertical line represents the isentropic compression, wherein entropy of point 1 is same as point 2, but the temperature rises from T1 to T2. That is isentropic compression. Next, constant pressure heat addition. For this, I will draw a constant pressure line, and when the heat is added at constant pressure, we'll start moving from point 2 to point 3 on this constant pressure line, reach up till point 3, and now we see that after the heat addition, the temperature rises from T2 up till T3. And there is even increase in entropy from point 2 to 3. So during the heat addition process, both temperature and entropy, they go on increasing as is shown by this line. Next, process 3 to 4 is reversible isentropic expansion. It will be shown with the help of a vertical line from 3 to 4, wherein entropy at point 3 is same as entropy at point 4. So S3 is equal to S4, but there is drop in temperature from T3 to T4. So here we have isentropic expansion. Then process 4 to 1, it is constant volume heat rejection. So here I am drawing a constant volume line joining 1 and 4. Now this line is having constant volume, and when we are rejecting heat at constant volume, we need to follow this line. Now the heat is being rejected from 4 to 1. As we see, there is drop in temperature from T4 to T1. Even the entropy decreases from 0.4 to 0.1. So this is the heat rejection process. As we see, from 2 to 3 the heat was added into the system. So this indicates heat addition QA. Next, heat was rejected from 4 to 1. So this is Q suffix R. Then as we see, during 1 to 2 there is compression process. So that is W suffix C, and 3 to 4 is expansion, that is W suffix E. Now with the PV and TS diagram completed, we can easily start with the solution, and the question was to calculate the efficiency of diesel cycle. We have to find this value. So I'll say that therefore efficiency of diesel cycle is given by, the formula is efficiency of diesel cycle is equal to 1 minus 1 upon gamma into bracket RC raised to gamma minus 1, next into bracket rho raised to gamma minus 1 upon rho minus 1 . So this is the formula for efficiency of diesel cycle. I'll keep this as equation number 1. Now if I look at equation number 1, to calculate the efficiency of diesel cycle we require gamma value, and gamma we can assume for air as 1.4. Next, RC is the compression ratio. Compression ratio I have calculated previously. The value was 12.04. Now the only unknown is rho, and rho is called as fuel cutoff ratio. So I'll write down where rho is equal to fuel cutoff ratio, and it is equal to volume after fuel cutoff to the volume before fuel cutoff. Now if we see that the fuel injection, fuel addition starts, heat is added from 2 to 3. So fuel injection starts at point 2, that is, this is the volume V2 before fuel injection, and then the fuel is sprayed from 2 to 3, and point 3 is the point where the fuel has been injected completely. So this is the volume after the fuel is cut off, because fuel cutoff takes place at point 3. This is the cutoff point where the fuel has been injected, and now the fuel injection stops at point 3. So volume after cutoff is V3, volume before cutoff is V2. So rho is equal to V3 by V2. I'll keep this as the second equation. So now in equation 2 we have V3 and V2. Now it was also given in the problem that the fuel injection is at 5% of the stroke, that is fuel injection takes place at constant pressure for 5% of the stroke. Now this statement I'll utilize, that since fuel injection takes place at 5% of stroke, which is nothing but stroke volume. So therefore, if I see the fuel injection volume, fuel injection starts at 0.3 and it will be completed up to 0.3. So fuel gets injected from V3 minus V2. This is the volume up to which the fuel gets injected. Next, the stroke volume is V1 minus V2. So of total V1 minus V2, 5% goes into the fuel injection. So I'll say that therefore V3 minus V2 is equal to 5% of stroke volume, which is nothing but V1 minus V2. Now after reaching at this stage, we can say that therefore V3 minus V2, I'll keep it as it is, 5% can be written as 0.05 of V1 minus V2. Now if we look into this, V1, since the compression ratio was given to us, and the compression ratio this we had calculated previously, I can say that also this compression ratio RC is equal to V1 by V2, because it is cylinder volume by clearance volume, and here the cylinder volume is up to 0.1 V1, clearance volume is only up to V2, so V1 by V2. Next, from this I can say that therefore V1 will be equal to RC into V2, and RC is the compression ratio, which is 12.04. So V1 can be written as 12.04 times of V2. So therefore 12.04 times of V2 minus V2, here I'll write down, since RC is equal to V1 by V2, and therefore RC V1 will be, RC is 12.04 into V2. Now from the calculation throughout, I will get it in this way, that 12.04 minus 1, which is the coefficient of V2, multiplied by 0.05, then this V2 would be sent onto the other side, it will become positive. So V3 will be in the form of V2, and the answer is, it is 1.55 times of V2. Next, I will put this value of V3 in equation number 2. I'll put the value of V3 here. So therefore put V3 is equal to 1.55 times of V2 in equation number 2. So therefore rho will be equal to, now this V3 is 1.55 times of V2 divided by V2. So from numerator and denominator, V2 will get cancelled out. So therefore rho is 1.55, that is, we have found out the value of fuel cutoff ratio. Now I can say that therefore put all values, that is RC compression ratio, rho fuel cutoff ratio, and gamma, that is the adiabatic index, in equation number 1. so that we can calculate the efficiency of diesel cycle. So therefore efficiency of diesel cycle will be equal to 1 minus 1 upon, it was gamma, and gamma for air can be taken as 1.4 into RC, the value we know, it is 12.04 raised to gamma minus 1, which is 1.4 minus 1. This is the first term. Next, into bracket, it was rho raised to gamma. Rho is 1.55 raised to 1.4 minus 1 upon rho minus 1, that is 1.55 minus 1. Hence, on calculating this entire term, I'll get it as, first of all, therefore the efficiency of diesel cycle will be equal to 1 minus, now this first term is 0.264 into the term in the bracket, this one is 1.54. So from this, if I calculate, I'll get the answer of efficiency of diesel cycle, which comes out to be 0.593, and if I multiply it by 100, my answer will be 59.3%. So that is the efficiency of the diesel cycle which was asked in the question. The question was to calculate the efficiency of the given diesel engine, and this efficiency we have found out, it is 59.3%, and with this the problem is completed.